Hi guys, today's topic is importance of abstraction in system design. Now imagine you're driving a car. You press the accelerator, stay, brake without thinking about how the engine, transmission or braking system works internally. That's nothing but abstraction, hiding complexity while exposing only what is necessary. Right? In system design, abstraction follows the same principle. It allows engineers to focus only on high level topics without worrying about lower level implementation details. Now, what is abstraction? Abstraction is the practice of simplifying complex systems by exposing essential features while hiding unnecessary details. I think this is something you might have already read in Oops. It's all about no, it's in the perspective of system design. It's it's just an extension of whatever you have learned in Oops, right? So I'll give you some examples so that you can revisit what you've learned in Oops. A shape, let's take a shape class, right, provides a common interface for circle, rectangle and triangle, right? Now each shape calculates its area differently, but users, any consumer of that API, will only have to call get area method without knowing the internal details, right? Now similarly, let me give you another short example. When using an ATM, you enter your pin and withdraw money. You don't see how the bank verifies your balance or process the transaction, how it deducts, or how it logs you out, right? That complexity of the whole system is abstracted away from you. You just have to enter your pin and withdraw the money. That's it. Now, why is even abstraction then referred in system design as one of the most you know central concept, right? It helps us manage complexity. Operating systems, for example, abstract hardware details. Developers don't need to manage memory, CPU scheduling, interact with any shell scripts internally or disk storage directly, right? So what is no the next point is it enhances modularity and reusability. Like for example, you guys would have used Django, Python Django, or Spring Boot, which internally handle the HTTP requests. You know, they also authenticate routing. They so developers at the end of the day only need to focus on business logic. Now, uh, another point is it enables scalability, right? Now, cloud services like AWS Lambda abstracts infrastructure, allowing applications to scale without managing any physical EC2 instances or literally the physical servers that are in the cloud, in the service centers of AWS, right? Now, uh, what are the different types of abstractions in system design? Obviously, there is, I have referred to it already in the video. It is OOP abstraction, like classes expose methods while hiding the internal logic. The next point is database extraction, right? Now, SQL is a very important tool that every backend engineer uses. Now, SQL hides indexing, query optimization, and storage management internally. It gives us just, let's say, couple of commands using which we can just implement indexing or manage the storage, right? Now the next point is network abstraction. Now URLs and APIs hide complexity of hide the complexity of network protocols. Like how does our request go to a DNS server? How does it go to the exact IP address? Right? All that is hidden. You just have to type the URL and you're there. Right? Now, what is like at the end, I would like to call it like abstraction is a very fundamental principle in system design. It simplifies complexity, enhances scalability, and improves maintainability, whether in OOPS, whether in databases, whether in networking, whether in cloud computing. Abstraction allows engineers to focus on only solving the real world problems efficiently rather than worrying about how the internal details of any system works.